Okay, so here we're looking for a situation that has a correlation but not a causal relationship. So that means since we're looking for something that's not causal, let's find all the ones that are causal and cross those off, and what remains should just be the thing where there's a correlation but not one that causes the other. So let me explain in general what they're talking about. So there's correlations all over the place, right? And for example, maybe in a city, you're studying the crime rates, and you find, very interestingly, that where there's lots of crime, there also, in those areas, tends to be, let's say, a bagel shop. And this might be an odd finding, but you keep looking into it. And it turns out in all the places where there is crime, somewhere nearby you can find a place that sells bagels. That's a correlation, right? Where there is one, there is the other. But that doesn't mean necessarily, of course, that, and hopefully, that the bagel shops are the cause of the crime. It just means that there's maybe lots of bagel shops. And since the bagel shops are everywhere and crime tends to appear, unfortunately, almost everywhere, the two can always be found next to each other, somewhere. So, assuming you're in an area where they do have bagels, you're going to find a bagel shop. That's the real reason you're finding bagel shops. But this is not causal, it's just a correlation. Causal means one thing causes the other. So I noticed that choice 1 is gone because the edge of a cube, or the side length of a cube, does affect the volume directly. That's causal. 2 is out because the time spent driving, right, does affect how far you've traveled. Also, 4 is out, although it's not really a good causal relationship, but in general, the number of classes taught, as there are more and more classes, you're probably going to have to hire more people to teach those courses, although there are ways around that, and it's not always consistent. So the answer is choice 3. And although it might be true that the age of a child and the number of siblings a child has, there might be a connection where the older children have more siblings because their parents have had more time to have other children. It doesn't mean that the fact that your child is older will cause you to have more children. Right? Think of any family where there's only 1 or 2 children. Right? I am over 30 years old. It doesn't mean that I'm going to necessarily have lots and lots of siblings or more siblings than someone who's even 12 years old who might have 5 or 6 brothers or sisters where I only have 1 sister, right? So there might not be a causal relationship here. In other words, the older you get doesn't mean automatically the more brothers and sisters you have. Okay, the next question. So we have these student scores, and we want to find the mean and the median and describe the effect of the mean and the median if Mrs. Mosher adds 5 bonus points to each of the students, 6 student scores. Okay, so I'm going to actually pull up the graphing calculator here just for good practice. You don't need to, but I think it's a good idea. So again, the way this works is that you want to enter this data into a list. Hit second stat. Here are my lists right here. Sorry. It's faster if I just hit the stat button. I want to edit my list. So press stats and then edit. Up here with the list heading, hit clear and then enter to clear your list. Let's go up, clear and enter enter in your data. So here we have 72, right? 80, 85, 93, enter, 78. And again, I'm showing you this because this can end up being super useful on some of these examples. Once you have this list, you're essentially done. Once you have your data entered, hit second stat. Here we go to the math column. Let's find the mean. And then I know this seems a little tedious, but it helps in much more complex problems. Second stat, list 1, enter. There's our mean, 81.3, right, to the nearest tenth, so 81.3. The median, we can quickly find that as well. Second stat, math, choice 4 is the median, hit 4. Second stat again, L1. You could also hit second 1 for list 1, right? Press enter, we get 80. Okay. Describe the effect on the mean and median if Ms. Mosher adds 5 bonus points to each of the 6 scores. So let's just go back, and we're going to do this manually, then we'll talk about the algebra behind it. So if I hit second list, right, oops, hit stat, edit, let's make a second list. So we add 5 to all of these. Instead of 72, I get 77, right? Add 5, 80, 85. 85 becomes 90. 93 becomes 98. 78 becomes 83, right? And 80 becomes 85. Okay. So now we can just go through that same process. Hit second, stat. And here we want to find the mean, choice 3 of list 2 this time, second 2. Notice the mean is shifted up by 5, right? So instead of 81.3, it becomes 86.3. That's the mean. The whole thing is shifted up 5 values. And let's see what happens with the median. So we hit second, stat, math, choice 4 for median, and second 2 for list 2. And that also has gone up 5 values. Right? The median is no longer 80, it's now 85. Essentially, both have shifted up exactly 5 places. And this makes sense if you think about the way mean and median work. Everything is moving together, and the whole mean and the whole median move with it. So I'm not going to look at the algebra here, we're going to get into that, but you want to really, I think, reflect on that instinct here of why that whole, since the whole data shift, since the whole data set is shifting up, then the median also shift up. All right, let's keep going here. Okay, so let's go over these questions. The scatterplot below represents the relationship between the number of peanuts a student eats and the student's bowling score. Okay, so I mean, I guess you can expect that this should have no correlation. It shouldn't really matter how many peanuts you eat. It should not affect your bowling score. And in fact, look at the data, how it's scattered all over the place. I guess you can kind of draw a line of best fit maybe like this, but not really. I mean, the data is all over the place. So here I would say the only valid answer is that there is no relationship between the peanuts you eat and the bowling score. Next, which situation does not describe a causal relationship? So again, we're looking for a relationship where one thing does not cause another. So let's look at these. The higher the volume on a radio, the louder the sound will be. Well, that is causal. So that's out. The faster a student types a paper, the more pages the paper will have. Not necessarily, right? You might be typing just a paragraph. We'll come back to that one. The shorter the distance driven, the less gasoline that will be used. Again, that's generally true, except we have to take into account the gradient. Are we climbing up a hill? What are we doing? Okay, let's keep going. The slower the pace of a runner, the longer it will take the runner to finish the race. Okay, well that is true generally, unless there are some serious obstacles, and the only way to get through them safely is by going slowly. But we have to kind of oversimplify these questions. Okay, I guess these are all, I would say, not really causal. But I would say out of these two, that 3 is more causal than 2, because right, if you're driving a less distance, you're probably going to be using less gas. It kind of is causal, and 2 is not causal because you don't know how many papers you're writing, how many pages you're writing in your paper. You can write extremely fast, but if you're writing a short paper, it will be shorter. The speed does not affect the length of the paper, only the speed at which it will be written. Moving on to the box and whisper plot. So the next one, this is, box and whisker plots are super common here on these types of tests. So let's look at this. Based on the box and whisker plot below, which statement is false? Okay, so the median is 7. Well, this line is always going to represent the median. That's how these things are designed. So that's true. The range is 12. Well, this number is the lowest or the minimum value, and this number is the highest or the maximum value. And that's from 12 to 2. So the range is actually 10. So that's false. The first quartile is 4. Well, this line is always the first quartile. And all that means is it's the value that separates your lower half of data into 2 equal groups. So that's true. The third quartile is this line right here. That just separates the upper half of the data. And it is 11, so that's true. All right, keep going here. Okay, the data in the table below are graphed and the slope is examined. The rate of change represented in this table can be described as, well, rate of change. As x is going up and up and up, what's y doing? Y is going constantly down. So that's called a negative, right, slope. or negative correlation, or negative rate of change. Positive would be they both go up together or down together, right? X could be decreasing, but Y would also be decreasing. That's positive. Or they're both increasing. Undefined would be a vertical, right, slope. That means if you think about a vertical line, the Y values are always changing, but the X values are never changing. So you might see all the same X values, like 1, 2, and 3. Sorry, the Y values are always changing, but the X values are not. So for X values, maybe this X value on this line is 1, and always 1. And the Y values are always different. That is undefined. Zero slope would be, of course, a horizontal line. And a horizontal line, the X value is always changing, but the Y is never changing. So X would be like something like 1, 2, 3, and so forth. And Y is maybe always at the number 4. So that would be a zero slope. Here, which set of data can be classified as qualitative? Again, well, qualitative is a measure of the quality, not the number value of something. So scores are based on numbers, ages are based on numbers, the numbers of students are obviously based on numbers. But eye color, you would tell me the color of the student. And it's true that color can be defined with numbers, and everything really can. But you're looking at the eye colors, you're going to use words like blue and green and blue gray and so forth. Those are qualitative measures, so choice 4. Okay, here we have a frequency table, and they want us to construct a frequency histogram. Okay, so we set up our y-axis, go up down to here, and our x-axis, and then I always determine next what those axes are. So the intervals are down here on the x-axis, right? That'll be your intervals. And here on the y-axis, that'll be your frequencies. So the intervals are already predetermined, right? 61 to 70 and so forth. There are 4 intervals. So here, right, we'll set my intervals up and make them continuous. So we can start at 61 and we go to 70, right? That's our first interval. And then 71 to 80. So we can just write 80 here. And then 90. And then 100. Right? It's implied here that you don't have to say or worry about that little gap right there. 61 to 70 is this whole range right here, and everything above 70 but below 80 goes in this gap right here, and so forth. So we can set those ranges up. Now we have our tallies: 5, 4, 9, 6. So we go by, let's say 2s: 2, 4, 6, 8, 10. And then you'll make this nice and neat, I hope, on your exams. But here is, right, 5 is about halfway here. So we get that. Okay, next we have 4. Okay. Then we have 9. It's about halfway here. And then last is 6. And then I guess here, put a title: Final Exam Scores. So here, with these histograms, it's a little tricky because of the gap here between 70 and 71. That might throw you off. But remember that if you, for example, draw this range 70 to 80, all you're saying is that there were 4 scores in that range. And with every histogram, you have to round up or down numbers that are on the line. We just happen to make this so that if you get 70, right, you round down because the interval is from 61 to 70. So if someone got a 70, they would be included in this group right here with a tally of 5. But if someone got a 71, right, this shows us that we round up to the next interval. But we take care of that here because 70 to 80, if we're always rounding numbers that are 70 and below down, anything slightly above 70 would naturally fall into this group. And they're only giving us numbers from 71 to 80, but that's okay. That'll still fall into this group. So we don't have to worry about those little gaps right there. They'll just fit naturally into this interval scheme. All right, let's keep going. The relationship between the independent and dependent variables in the scatter plot is shown below. What is it? It's about, you can draw a line of best fit here that kind of represents this data. It's a line that kind of reduces the distance to all the points. And that looks like this, I think, right? It's a fairly good drawing here. Undefined would be a vertical line. No correlation would be this points are scattered everywhere. Negative correlation would be a line where the height decreases as x increases. So this is a positive correlation, or just like a positive slope. What is the range of the data represented in this box and whisker plot? We'll just use these two endpoints because this is the minimum and this is the maximum right here. So max minus min is always your range. But the interval they're choosing right here is by 5s. 5, 10, 15, 20. Right? 5, 10, 15. This is 15. So 75 minus 15, that's our range, and that's 60. Let's keep going here. Which data set describes a situation that could be classified as quantitative? Quantitative means that it's being defined by the numbers we use. Qualitative, in comparison, looks at the quality of an item. Not if it's necessarily good or bad, but like maybe a flavor of an ice cream, a color of your eyes, and so forth. The phone numbers in a telephone book is certainly quantitative because we can look at the number of numbers. However, if we're looking at the actual numbers themselves, this is kind of interesting, right? If someone's number is, whatever it is, that's not necessarily quantifying it in the sense that you're ranking it or measuring it. It's just giving it a number or assigning it a value, kind of like we assign chocolate ice cream. The word chocolate means something, and your phone number means something, but it's not really a ranking system. I can't say my phone number is greater than yours because the numbers are higher. I guess I would have to call this one qualitative, so we keep going. The addresses for students. So again, addresses use numbers, but you can't really say someone's address is greater than the others. It could be after someone else's or down the road further, but not really, right? Not really quantitative per se. Zip codes, same thing, qualitative. The time it takes for each person to complete a test is quantitative. If someone has a higher time, you can say they took longer to take the test. So it's certainly quantitative. The closest candidate for quantitative on the other three choices, I think, is the addresses, because addresses, again, if your address is higher, that means you're further down the road. It means something, but not in the traditional sense that perhaps score values or time measurements really indicate. So time is a typical quantitative measure. All right, a couple more to go. All right. Sam's grades on 11 chemistry tests were the following. Which statement is true about the measures of central tendency? So here, I'm going to use the calculator to help. Let's go into our lists here. We hit the stat button. And want to edit a list. Let's make a third list because our first two are taken. And you can enter these numbers in any order. It's part of the nice feature of the calculator. It will sort everything out for you. 90, 85, 76, 63, 94, 89, 81, 76, 94, 89, 81, 76, 78, sorry, a little lag here, 69, and 97. All right, and we're basically done now. We quit out of this. It's automatically saved. Hit second stat, go to your math, and want to know what the mean is. So hit 3 for our third list, second 3. So the mean is about 81.63. Oops, that is the mean. Then what's the median? Let's get that one next. So second stat, math, median is 4 of list 3. The median is 81. So this choice is out. The median should be less than the mean. This is out. The two are not equal. They're close. The mean is greater than the mode. What is the mode? Let's find out. Second stat, math, and here, maybe they don't have mode on here. Interesting. Maybe there is a way to find mode. I'm not sure if I know it. Let's just look at this list and find the mode. The mode is the thing that's most repeated, or repeated more than once. Here, we have 90, only repeated once. 85, once. 76, I see it appearing twice. But let's see if any other numbers appear more than that. 63 does not appear more than once. 94 as well. 89, nope. 97, 69, 78, nope. So the mode is 76. So the mode is greater than the median. And the mode is greater than the mean, but the mean is not greater than the mode, so that's out. So choice 3. Almost done. Here are the test scores for students in the class. So complete a frequency table below. Alright, so how many people are between 51 and 60? I want to cross them out as I go. 52 falls in there, it's 1. And I only see one person in that range. Nope, 258. So 1, 2. 2 there. And next 61 to 70. So 61 to 70, 64 is 1. I only see one person in that range, so 1 and 1. 71 through 80, so 1, 2, 3, 4. 4 people. 1, 2, 3, 4. I see 68 there, I missed that one, that goes here. Okay, keep going, 81 through 90, so 1, 2, 3, 4, 5, 6 people, 1, 2, 3, 4, 5, 6. And then 91 through 100, I'll just check, it's 1, 2, 3. 1, 2, 3. Draw and label a frequency histogram on the grid below. Okay, so histograms, right? Intervals on the x-axis, frequencies on the y-axis. So we set up our axes right here. This was a nice, straightforward histogram, but let me just get these lines set up. There's my x-axis, there's my y-axis. The intervals here should have no gaps between them. So 51 through 60, I'm going to go from 50 to 60, right? It has a similar idea. Let me just narrow that plane. So that's 60 right there. This would be 70, 80. All right, you know, I don't have that much room, sorry. Let me just adjust this. 60, 70, 80, 90, 100. So 60, 70, 80, 90, 100. This will not change your data, right? Because the interval 51 through 60, this first one, falls in my interval 50 through 60. As long as I say anything that equals 60 is still included in this range. So our frequency there is 2. So we plot that. You would do that with a ruler, of course. And the next one, 61 through 70, falls in our range of 60 through 70. So here that means we have 2 as well, right? And just as long as anything that hits 70 gets still put into this range, we're okay. 71 through 80 has a value of 4. It goes up here, right? Of course, it'd be neater with this, 3, 4. And then we keep going. 81 through 90 is 6. Okay, so 5, 6 up here. Oops, we should change colors. Okay, 5, 6. You will label this neatly, I hope. And then 91 through 100 is just 3. So that's right here, 1, 2, 3 as well. And that's it. You want to give it a title. Let's see what was this about. I don't even know. Test scores, of course. Test scores. And we're done. Oh, sorry, label the axes. We have the intervals, or scores, and the frequency. I don't think you would normally label this, but I think for this exam, don't give them any excuse to take points off of your work. Okay, the survey is being conducted to determine which school board candidate would best serve the community, which group, when randomly surveyed, would likely produce the most bias. Okay, again, with surveying, you have a population to look at, right? But you can't survey everybody. You want to pick a smaller sample, right, that represents the most people possible. So here, let's see which of these groups are not representative of the entire community. 15 employees of the school district. Well, that's really going to be biased because everyone is going to only be working at the school. So their influences will be driven by the school, not by everything the community needs. 25 people driving past the school will certainly produce less bias. We don't know where they're going. It could be going to random places, although still that might be pretty biased because they're all working near the school probably or living around the school. 75 people who enter Yonkers grocery store is even better. It's a larger sample set. 75 is larger than 25 and 15, and they're shopping. Now everybody needs to buy groceries. We're assuming that the people in the grocery store, unless it's some kind of really high-end or low-end grocery store, will be less biased. 100 people who visit the shopping mall. Since most people are able to go shopping, It's not going to represent everybody in the community, especially the people who can't afford to go shopping. But 100 people there will be better than any other choice here, or at least or less biased. The worst is the smallest sample size here, um, because they all work in one place, not just because it's the smallest group. All right, keep going. Last problem. The maximum height and speed of various roller coasters in North America are shown in the table below. Which graph represents a correct scatter plot of the data? I just tend to look at the trend or slope here. I notice that um, as the speed increases, right, what happens? Well, our heights generally increase, and then the last one decreases. So as our speeds are increasing, this one looks pretty good, right? The heights are increasing, except for the last one where the height drops. And in no other case does that really happen, except here, max height, right? These are identical, except one's connected and one is not. And I would rather choose choice 2 because choice 3 connects this scatter plot, right? And that's really a line graph. A scatter plot itself is just the points. And here the other ones, as the height increases, uh, the speed increases as well. So here, but look how they set this up. Maximum speed should be on the x-axis. So even though 1 and 4 do have the correct points, I believe, the axes are switched. They give you the axes here. And again, 4 would be out because they connect those dots. And we don't know what's happening between. We're just getting a scatter plot, so we don't connect those dots.